laws and filling in your notes. So if you could follow along with me in those notes, that would be good. So we're going to start with multiplying powers with the same base. Now what we're going to end up doing in class is we're going to be doing some examples in pods and trying to figure out these laws and this rule for ourselves first. So if you're struggling a little bit, let's go through the examples and let's kind of figure that out. So the first thing we need to figure out is we know that x to the fifth means x times x 5 times, right? So when we're talking about when I ask you to expand, when I would ask each group today to expand, it means to write it in the longest way possible. Okay, and then simplifying would be writing it in the shortest amount of symbols possible. Okay, so for example, here's the first one. So example 1 is f to the 6th times f to the 5th. So what that would look like, what does f to the 6th means? Well, that means f times f times f times f times f, 6 times. So if we were to write that expanded, it really looks like this. So then we look at this and go, okay, is there any way we can simplify this and write this in the smallest way possible with the fewest amount of symbols, right? Well, if f times f times f times f and on and on and on and on, how many f's do we really have? We have f to the 11th. Now look at the exponents that were in the original problem. Where could that 11 possibly come from? Think about that. Okay, back to the next example. So this was what group 2 got. Group 2 got this. Well, what does y to the 8th mean? Y times y times y. And then y to the 2nd means y times y. So we look at this and go, okay, how can we write this in the shortest way possible? Well, how many y's do I have? I have y to the 10th. So look at the exponents. In the original problem, look at what it was simplified. Let's see. Let's go on to a next example. So example number 3 is 2 times d to the 3rd times 6 times d. So this is a little bit different. We got to think, okay, what is the exponent? So I see that 3 is an exponent. What's the base? Is the 3 attached to the d, or is the 3 attached to the 2d? Well, the 3 is only attached to what's before it. So what it really looks like expanded is this. 2 times d times d times d, because the 3 was only attached to the d, and then times 6 times d. So is there any way we can rearrange this a little bit? Yeah, because if we multiply 2 times 3, 3 times 2, it means the same thing. So we can rearrange this to help us out a little bit. So if I were me, I would say, okay, the 2 times the 6 first, put the numbers together, and put the variables separate. So really, 2 times the 6 is 12, and then you have 4 d's, so d to the 4th power. So this is the third example. The fourth example looks like this. Something kind of similar. So you have to ask yourself again, what is that exponent attached to? What's really the base for the exponent? And it's really just the x. The x is the base here for the exponent. So it's 7 times x times 4 x's times 3 more x's times together. So if I could rearrange this and if I could write all of these all simplified out, you've got a 7, that's as much as I can simplify that, and then simplify the x's, you get 7x to the 9th. Okay, and then, so think about where could that 9 come from? Okay, the last example looks like this. It's kind of similar to that other one that we did, and we got to think to ourselves, okay, we've got 3x squared times 5y to the 6th. So what is that squared attached to? The x, or is it attached to the 3x? So really it's just attached to the thing right before it. Oops, ignore that. It's attached to the thing right before it, so it's just attached to the x. So it looks like this. 3 and then 2 x's and then a 5 with 6 y's right after that. So could I rearrange this? Absolutely. I would put those two numbers together, the 3 and the 5 together, to simplify it, and then my x's and my y's. So this simplified is really the 15x squared and then y to the 6th power. So really the only thing that we could simplify down was just really the number pieces by rearranging those numbers so that they went together. Okay, but look at the exponents, those ones stayed the same here in this case. Okay, so back to my examples here. So I'm wondering if you caught on, where did those exponents come from? So if I looked at this one again, it was the 8 plus the 2. And if the bases were the same, how many D's did I end up with? 3, 4 D's at the end. So where did those exponents come from, or where did that come from? That came from 3 plus the 1 gave me that D to the 4th power down here. So here's our notes now. So on the outside, so find the multiplying powers with the same bases. Find your multiplying powers with the same bases on your notes. And then here are the examples that go on the outside of your foldable. Okay, so a to the 5th power times a to the 7th power, and then 3x to the 6th times 4x squared. This is nice because you'll see an example now that has only variables, and you're also going to have an example now that has numbers on the outside as well as some variables with exponents, so it has a little bit of both for you. Okay, so open up that foldable then, and inside the tab is the rule. When we have same bases, and you can put the answer inside the flap as well, so put the rule inside and then put the answer inside the flap. Or you can put it on the outside as well, whatever you desire. So when it comes to this, our rule is we add the exponents with the same bases. So if they have the same base, we add the exponents together. So really, a to the 5th times a to the 7th means I have 5 a's plus the 7 more a's. So a to the 5 plus the 7 gives me a to the 12th. On this one, I am multiplying the number pieces, the coefficient pieces, together. And then I can go ahead and add my exponents together. So 3 times 4 gives me 12, and then x to the 8th power by adding the 6 x's and the 2 x's together. So really, we should add the exponents, and then we should maybe make a note up here in the rule, multiply coefficients, so that you have it in your notes. Multiply coefficients as well. Okay, so we're going to do some more practice with this now. So these would be the examples that we would be going over in class, and these would be, I would have pods work together to go through these ones. So the first one, you can just try them. If you want to pause them, try it now and then go through as I go through the answers. Absolutely a good idea. So if I look at these, I see my bases are -3 times -3 times -3 times, so I have that 5 times. So really it's -3 to the 2 plus the 5. So it's really -3 to the 7th power. You have to have the parentheses there because the base is negative. B to the 4th times b to the 5th, both two bases are the same. So it'll be b to the 4 plus the 5. Means I have 4 b's and 5 b's, add them together, b to the 9th. For these ones, I'm only going to look at my bases that are alike. So remember, if there's only one of them there, my exponent's really a 1 right there. So if I look at this and go, okay, how many m's would I really have? 3 m's here, 1 m here. So I would have 3m to the 3 plus the 1, and n to the 4th power plus n squared would give me m to the 4th plus n to the 6th. Okay. Then the last one, coefficients get multiplied together, so 2 times 4, and then I've got 5 x's total between the two of them, x to the 3 plus 2, so I would get 8 x to the 5th is what that one would look like. Okay, so that's really some extra practice with this rule, multiplying powers with the same bases. Okay, now we're going to do another rule that's also very similar in class as well. So I'm giving these to pods, and we're going to be kind of expanding and looking at these same ideas, but we're going to be doing dividing instead of multiplying. So the examples that we're looking at would be this one. So if I have m to the 7th divided by m to the 2nd power, well, if I were to expand that, it looks like this. Well, how could I really simplify this? Well, if I had an m divided by an m, that really cancels it out and it equals 1. So these two cancel each other out. This m cancels out this m. So really, what am I left with? I'm just left with 5 m's because two of them canceled each other out. So m to the 5th is really what this one is. Now if you look at that, look at your exponents. How could I possibly have gotten that 5? Keep that in the back of your head. We're going to go back now and we're going to look at example number 2. Okay, so if I had 3 to the 8th, so this is just an example that is numbers instead of variables.
I was just informed that they need to take Power School down very shortly, so if you need to do something quickly in there,
So that's what that looks like expanded. You have 8 of those and you have 3 of those on the bottom. So if I were going to simplify this, that one, 3 divided by 3 equals 1, so that cancels each other out. This 3 divided by this 3 cancels each other out. So what am I left with? 5 3's, 3 to the 5th power. Now look at your exponents. Where did those come from? Okay. Back to my examples. Let's do example number 3. Now this one expanded 10 times b times b times b. So those are what that looks like. So now let's look at, okay, how could I simplify this and write this in the smallest way possible? This one cancels, this one cancels. Well, what is 10 divided by 5? Let's actually divide our coefficients out. You end up with 2. 10 divided by 5 is 2, and then you end up with 1b left over. So that's 2b. So 10 divided by 5 gave me the 2, and then how could I get b really to the 1st power here with those exponents? So keep that in mind. Okay, example number 4 looked like this. So if we expanded this one out and we wrote it like that, there's all of our 6x's, 8y's, all that good stuff. So if we were to simplify this one out, cancel, 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 all of my x's just canceled each other out. And then y, this cancels, and this cancels. So what am I really left with? The only thing I've got left over is y times y times y, and I can write that y to the 3rd power. So look at your exponents, think about where that's coming from. Okay, the last example looks like this. So 21 b times b times b, if I could simplify this, well, I can simplify out my 21 divided by 3 pretty easily, cancel out your b's, so you're left with 7b. Okay, so if you haven't figured it out yet, here's the rule. Here's the examples that go on the outside, so find that tab that says dividing powers with the same bases. Here's your examples that go on the outside of your notes. You've got one with variables, and you've got one that have actual numbers in it, because you could see it written either way. Okay, examples on the outside. We'll put answers and the rule on the inside. So open up that foldable, and here's the rule. The rule itself is subtract the exponents with the same bases. Okay, and we divide any coefficients. Okay, divide any coefficients as well. So how do we do that? We're really subtracting our exponents. b to the 25th minus 5 gives me b to the 20th. I would have 20 b's left over, and then 4 to the 6th power means I have 4 to the 6th minus 5, so that means I have negative 4 really to the 1st power, but we don't necessarily need to write it with the 1. It could just be negative 4. It just means I have one of them left over. Okay. Here's some examples, other examples that we're going to go over in class. So here would be the 3 examples that I would say, okay, work with your pod and try to figure out these answers. You should try to figure these ones out right now. Pause me, find the answers to these, and then come back and check. So here's the answers. So b to the 3 minus 2 gives me b to the first power, or just b. You don't have to write it to the first power. These ones, we're just looking for ones that have the same bases. So x to the 12 minus the 7 and y to the 18 minus 10. It looks like that. Okay, so we would be left with 5 x's and 8 y's that didn't cancel out. And then this one has our coefficients in the front. So we need to simplify the coefficient or divide out the coefficient. So we really have 2 to the x 4 minus 1, y 7 minus 1. So it really is 1/2, or you could put a 0.5 in the front. There's nothing wrong with that. X to the third, y to the sixth is really what this one ends up being. We had a couple other problems that we decided that we would do, and this same idea. So for this one, we would get 2 over 6 is really simplified 1/3. And then we would have x to the 4 minus 2. So that would be x squared. And then y to the 6 would have nothing else to simplify. So y to the 6 minus 0, nothing to subtract. Okay. If I had these ones, x to the 5th divided by x to the 5th, x to the 5 minus 5, these really all cancel out. Those are gone. Okay. Y to the 3 minus 2 gives me y to the 1. And z to the 7th, and that's really a 1 right there, z to the 1. So z to the 7th minus 1 gives me z to the 6th. Or, so this could be written y times z to the 6th as well. Okay, so your homework will be provided to you as well for this idea, and this will have both concepts of the multiplying with the same bases and dividing with the same bases.